record and say hello. Happy Thursday. Happy Not Garbage Day. Eventually we'll have spring, but not yet. We'll keep working on it. So next week, I was just looking at the syllabus here. Monday's due date is for project outline revisions. Does anyone want to ask anything about that if you're working on those? The idea is that I withheld a couple points to provide incentive so that we can make sure that I understand what you're planning to do, and more importantly, you understand what you're planning to do. So, does anyone want to discuss that at all? No? Okay, well, email, office hours, always open. If you have lingering questions, I will try to get those back to you as soon as humanly possible, since we only have 2 weeks of classes, regular classes left, and then presentations start after that. So we're closing in on the end of like the content portion of the program in terms of my side of things. So I'm excited about that. I get to be you. Except I have to pay attention and take notes because I have to give you feedback. But otherwise, yes, I have to remember how to use a pen to do that, I think, since my computer will be up here. That will be the greatest difficulty of all of it, is actually writing like a person again. All right, so then let's see here. We were talking about mediation of longitudinal data last time. Does that sound familiar? Yeah? Cool. So this is the story. Just to reorient us, here's what we're talking about. This is data from chapter 8 of my book, where we're in the context of a daily diary kind of study, where we're asking folks for, I think it was once a day for 5 days if memory serves, about whether or not a stressor happened to them. So that's level 1 stressors, no or yes, as a binary box here. Whether or not, actually, the extent to which they had symptoms of negative mood, so that would be a Likert scale type of thing with a bunch of items. And then the number of physical symptoms that they had that particular day, which is a checklist of all the things that you can feel bad about, headache, nausea, pain, etc. And because stressors is binary in this context, I am leaving it as a box in the model as opposed to a circle indicating a latent variable. That is because within this version of the model, so this is a multi-level structural equation modeling setup, at least to begin with, we are unable to treat predictors as outcomes, to trick it into bringing them in the likelihood if the variable in question needs a link function. So you can't have generalized outcomes in the likelihood as outcomes if they're not truly outcomes. A workaround to that, of course, is if you fit it as a single level structural equation model, in which case you would have random intercept factors predicting stressors, then they are actually outcomes, and then they can be in the likelihood, and they can have missing data, and they can be binary. So there's a lot of like permutations of what can and can't be done, and it's all based on what is programmed and anticipated by the software. That's all. So we went through the X to Y path here from stressors to symptoms, and then person mean stressors as an observed level 2 counterpart from X to Y here. And I have this path labeled as BP/context. In this case, which is it going to be? If I have original stressors at level 1 and person mean stressors at level 2. This relationship at level 2, is that between person or context? What do we think? Got 1 vote for context. What do you think, Zoomers? 2 votes? 3 votes? It might be unanimous. Almost unanimous. 1 more vote. What do you think, Ryan? Context or between? She votes context. Okay, it's settled. Yes, it is. And we know that because yes or no stressors still has between person information in it. It has not been person mean centered. Therefore, it is the unique effect of daily stressors after controlling for the person mean, which makes the within. Controlling for the person mean, or controlling for stressors then forces this to become a context effect. What the other ones are depends on how we set it up. So that's the pro. So I have words here describing the idea here. Do you want to go back over any of the code for the first model that we looked at? Hello? In terms of the boxes of stressors predicting symptoms, we had that analogously in Stata Mixed and Elmer, as well as in the MSEM framework in M+. Do we want to go back over any of that or talk about any of that? No questions? Feeling okay with that? Okay, cool. Then let us continue on. So step 2A, foreshadowing that there is also a step 2B. I want to show you two different ways of setting up the same model because they are going to render different kinds of results. So I want you to anticipate that and know which one you will need. So 2A here, this is the M to Y path. So now we're talking about symptoms as the Y being predicted by negative mood as the mediator, which is a predictor in this model. So on the left-hand column here, let me zoom in on this. I call this step 2A-ish because from a conceptual point of view, it's analogous. We have negative mood as a predictor that's carved up into, actually, in this case, no, I did not carve it up. I kept it the same. I have time-varying negative mood centered at 2, and I have person-mean negative mood centered at 2 as well. So I have the negative mood side predicting the symptoms, but I'm using observed variables to do it. So mood 2 and person-mean mood here, as well as in stated code. So that means that the models are not equivalent in the sense that mood is not being treated as latent, it's being treated as observed. But we can walk through the results here and get some practice with that. Haven't done this kind of thing in a while. Let's bring it back. Yeah. So my intercept is 3.3-ish. What is that telling me? Anyone can play. Free for all. My outcome is count of physical symptoms that day. And yes, that should probably be a Poisson model or something, but this is hard enough.
So physical symptoms for men at age 20 with mood of 2.
Age 80. It's old people,
Age
but yes,
80.
close enough. With a mood of 2 that day.
That day, and then a person mean mood of 2 overall.
Yep, that's exactly right. So that's our reference point for the model. Then we have what looks to be a main effective gender. That's predicting the intercept. So I could say that women have fewer symptoms by 0.5 on average. However, that's not the end of my sentence, right? What am I forgetting? Age 80, yeah, the interaction term. So 80-year-old women have about a half a symptom fewer on average. What about age? Looks like that's slightly positive. What happens to symptoms as you get older? They go up a little bit. Yeah. Trust me. I'm here to tell you that it's accurate. But this is in men because of the interaction term. So in women, the pattern is actually backwards. So it takes it from a slightly positive slope down to a slightly negative slope. And this is my least favorite kind of interaction term because it's like what it means is that this one's barely positive and this one's barely negative and they're sufficiently different from each other that the interaction is significant, but neither simple effect is really worth writing home about. So that happens fairly often, I would say. Then this is my within person effective mood, right? Since we've controlled for person mean mood. So for every unit more grumpy I am, we'll go with that today. My symptoms go up by 0.16 that day, concurrently, not significantly. So on a given day, if you're grumpier than usual, you don't feel sicker than usual. What about person mean negative mood? What do we do with that one? Coefficient is 1.81. What does it mean? I'll just look at everybody.
After we consider the person's mood for that day, it's
Mhm.
the additional contribution of them being grumpy just as a human.
Yes, after we consider the mood for that day. So we're putting this into the language of a contextual effect. This is the effect of being a grumpier person than other people. And for every unit more mean grumpy you are, whatever that means, your symptoms go up by 1.8. So we'd have to know what the distribution of this variable is to get a sense as to what a unit is. If memory serves, it's like on a 1 to 5 scale. So if you move up a full point on the scale, then your symptoms would go up by almost 2. And that is significant. 2 scientific notation levels. And if we want a between effect instead of a contextual effect, what do? No, you're not going to sing? Anyone want to sing? Okay, we're singing. Add them up, up, up. Yep, add these up. That becomes the between person effect, and there it is right there. Okay, so that's review-ish. If I wanted to test a random slope of within person negative mood, can I do that? Can the extent to which if you feel grumpier than usual, you feel crappier than usual vary across people? I think it could. Can I do it with this variable? I cannot. Why not? It has level 2 in it. Yeah, so even if you want to have a within contextual version of your fixed effects, which is reasonable in many cases, you cannot have the right kind of within slope be random because there's no analogous contextual effect to fix it on the random side. So if you are using constant centering on the fixed side to get contextual effects at level 2, you cannot do that on the random side. You would have to make a new variable that is person mean centered to put in there instead. Before I even built this examples, I did go through and test all the random slopes for the level 1 model. Let me go back up to the picture here for a second. So each of these, how many random slopes are possible according to this picture? You gotta vote for 3? Another vote for 3? Gonna vote? Everyone's voting. 3. 3s and 3s. Yep. Each of these paths could conceptually be random. So the extent to which having a stressor makes you grumpy can vary across people. The extent to which being grumpier than usual makes you feel crappier than usual can vary across people. And the extent to which having a stressor on a day makes you feel crappier than usual can vary across people. Now, if I had that, I don't, because I'm trying to be nice, this is hard enough as it is, where do they go in my picture? Clearly there's no room to make the picture bigger because it's surrounded by words like fencing, but if I had random slopes, where would they go? We even talked about this. I'm looking for you to guess. Taylor, go for it.
Like a separate set of circles, right? Like the change circles.
Uh-huh. Like the green change circles that were random effects, as we used to call them. Do they go in the level 1 part of the model or the level 2 part?
Level 2 part.
Mm-hmm. Yep, I would have 3 new circles floating up here, and I could have relations among them as well as relations with the things also floating up here. So yeah, random slopes then, the way that it's notated in M+ diagrams is often like a filled circle on this line and then an arrow connecting it to the circle that would be up here, is the way that they notate that. It's a little kludgy, but point of the story, if you have a random slope, last semester was all about random slopes for time. We're expanding what it can be to random slopes for any time varying predictor. Those become level 2 outcomes that you can then predict or be predicted with other things, just like the intercepts. There is some literature on testing indirect effects in mediation that involves random slopes. If anyone is in that situation, let me know and I'll send you a couple articles. It turns out that the covariance between the random slopes and with something else has to be included in the indirect effect or it's wrong, and I can't remember the exact way that that works, but someone figured that out a while ago. So I will track down those articles if you're interested, but I was able to avoid them because there's no random slopes in the data for this particular example. Okay, making that point. All right, so we're cool with the side, this side, right? Any questions on just the output we just worked over? We good on that? Okay, now let's do it on this side. Whole new ball game. So I'll zoom in here. So all the stuff related to data, define, and analysis are the same as in the previous model, so I did not print those. But we have changed the code in making M latent relative to when we had an observed X in the previous model. So one of the changes is right here. You see the blank spot before the semicolon? I left that in here to make a point. You would not have to write this in your code. Within equals nothing, doesn't tell M+ to do anything. But we used to have something there. In our previous model looking at stress predicting symptoms, what used to be there? Which one? Regular stress, OG stress. Yep, O1, yep. So that is gone because we're letting the model carve up negative mood into its between and within parts. So we're not putting it just at level 1, we're not putting it just at level 2. So by not writing it, you're actually asking M+ to do things. If that's not backwards, I don't know what is, but that's the logic. That it defaults to making everything everything. And if you don't want that, you have to shut the pieces off. I don't make the rules. So we have nothing within, and the only things that are in the between, these are boxes at level 2. And they are age, gender, and their interaction as an observed variable box that we made ahead of time. Could I make these latent? If I wanted to? Could I turn them into circles? I could. Now, from a measurement point of view, would that make any kind of sense? No, like, do I need indicators of age? Like how old you were in January and how old you were in February and how old you were in March? Something like that? No, we don't need that. Don't need multiple indicators to guess one's gender when it's self-reported, and there's no one's going to argue with you. However, you can actually turn these into outcomes in the model, which would technically make them like random variables that have an error variance if you had missing data. That would be a situation in which you might want to turn them into outcomes to be predicted. For age, I don't think that would be much of a problem, but for gender, it's binary. So that then would cause problems potentially. So I'm treating these as observed level 2 predictors. Therefore, any missingness would kick that person out of the entire analysis. So list-wise deletion happens for predictors that are not part of the likelihood still. So this technically is a multivariate, multi-level model. What makes it multivariate is that rather than having stressors be observed predictors, as we had last semester, we now have negative mood as latent predictors. So mood is still predicting symptoms, but each of those is considered an outcome from the perspective of estimation. So in the within model then, symptoms has a variance, right? In the within model, we call that residual variance at level 1. What do you think we called this one? Ding, ding. Any guesses? Residual variance at level 1, it's the same. So when you see the name of a variable, it's its variance we're talking about. And then you have to figure out if you're in the within model or the between model as to what kind of variance. But this is why like you don't see the word intercept. Like it's not specific enough because you can have multiple intercepts, you can have multiple slopes. Question from the Zoomers, is it possible to make a binary predictor with missing data into an outcome? I think that's what I have going on in my project. Technically, yes. In M+, I have not been able to get it to work. I think if memory serves, I was able to get something to work in Bayes when I switched over to that. What you might end up having to do, so this would put it into MSIM, by the way, not univariate MLM. What you may have to do is have something predict gender, even if that doesn't really make sense, so that it can be an actual outcome. You might have to drag some other variable into the story just to make it work. Otherwise, potentially hacking it with Bayesian estimation. It is, let me see if I have it in the example that we're working through. I feel like I did this, but there's like 8,000 models in there, so it's entirely possible that I did it at some other point. No, I don't think I gave you that one, but I know I've tried it before. So if you can send me an email to remind me about this, I can try to dig up an example of what that would look like. But that is the trick of having, turning predictors into outcomes to allow missingness on them. Otherwise known as FIML, full information maximum likelihood. So far we've got 2 residual variances, right? Which one of these is actually residual in terms of leftover? Got one vote for mood. You'll have to decompose this next sentence to get the answer to that. In this phrase, which is y and which is x? It's backwards from how I always think about it. Which is y and which is x in terms of this? M is my notation, but which is the outcome and which is the predictor? Well, I say it that way. Symptoms or mood? Symptoms. Yeah, so when statisticians talk about regression, they say they're going to regress y on x. I never ever say it that way because it's backwards to me. But what helps me remember is if you turn this on into an equal sign in your head, and then it looks like computer code, like it looks like an equation. Y equals and then my x's. So symptoms is being predicted by mood at level 1, which means that this symptoms variance that we're asking for is not just level 1 residual variance, but level 1 residual variance left over. Two different definitions of residual at the same time. There we go. So what this is doing, this is what I refer to in various readings I've given you as placeholder notation, because it's being set up the same way as it is in traditional hierarchical notation for multi-level models. Like this name, within person M2Y, is the name that I'm giving this new variable that I'm creating. Like in a traditional multi-level notation system, like I'd call this beta 1. Like at level 1, you're setting up the idea that this slope is itself going to become a variable that is predicted at level 2. Rather than use beta 0, beta 1, beta 2, I named these in a way that made it easier to understand what the code is doing. But conceptually, like I'm building beta 1. And then I'm saying what beta 1 is going to refer to, which is the prediction of symptoms from mood. So now this beta 1 is a latent variable that gets specified at level 2. So let's go down. Any questions on that so far? All right. Things in brackets. What are those? Yeah, intercepts or means. So I call these fixed intercepts. Symptoms is going to be specifically an intercept because it's being predicted by mood. Mood is not being predicted by anything. So this would be analogous to having just the fixed effect of within person mood as the center of that variable, as the mean of the latent variable. So in that case, other folks might call it a mean rather than an intercept because it's unpredicted. And when we get to the output, that is indeed what it's going to say. But in our notation system, if we think about these as like the starting point of the equation, like these are the fixed intercepts, gamma 0, zeros, one for each. And if you are like, can I please see an equation already instead of all these pictures and circles and stuff? Stay tuned. Here's some words where we're headed. And here is the model that we're building up to. So like right now what I have is beta 0i y and beta 2i y. And note that I had to add m's and y's because there's multiple things being predicted, and I had to find a way to notate which term, which outcome a given term was going with. Sometimes I put them in as superscripts. That sometimes gets confusing because then it looks like an exponent, like you're squaring something. So I stuck them on the end as letters this time. Notation is always author specific. It's fine. Okay, back. I think we were here. Yep, step 2. Cool. Okay. Now the next two, symptoms and mood in the between model. Outside the brackets, those are random intercept variances. So that is the random intercept variance for symptoms I'm referring to. That is what it is for mood. So far in the code, there is only one line that I would have had to have typed. Everything else is an implied default. It's this one. That's the only thing that I would have had to have typed. When you say, put symptoms in the model and put mood in the model, and you don't put them on the within and betweens, it automatically gives you, as a default, a residual variance at level 1, a random intercept variance at level 2, and a fixed intercept at level, it's considered at level 2, but the fixed effects are kind of hard to pin down. It becomes a semantic distinction at some point, but they're specified in the between model. So only this is really what I had to type, and these two then come next in referring to that.
So you didn't type it, it would still show up on the output of the output?
Yeah, like if I didn't type any of this, it's still going to be in your output. Is that displeasing? I have some frowns. I find it convenient and also bad at the same time. Because what happens when, like, I help people troubleshoot code is that their code looks really simple, but then, like, their output is like this. And it's like, okay, what all is in your model? Because you didn't ask for it. It just showed up. And they may not necessarily understand what's all is in their model because they didn't ask for it. So even in my life, like, not when I'm teaching, like, I write code so that I know what is happening. Like, I know what's going in, I know what's coming out. And I know what it means. Like, I put labels here even when I don't need them because it's helpful to me as breadcrumbs that I've figured out what this has to mean, and then I can look back on it and know. But yeah, same is true of these two right here. These would be defaults after invoking this at level 1. So we are building a new level 2 outcome that is the relationship between mood and symptoms at level 1. So we're building a random slope latent variable. The mean of it is right here. What would we have called that last semester? What's the mean of a random slope, essentially? Yeah, the fixed slope. So it's fixed plus random. So technically speaking, random effects have means of 0, but conceptually they're put together when you specify it this way. So it's like the variable itself is within person m to y. The center of that variable, the mean, is the fixed effect. And then the variance around it is the random slope variance. Now in this case though, I didn't want that, so I shut it off. So you would have to write that if you didn't want that. The rest of these, you would have to write, because it doesn't understand what it wants to do with the rest of the circles and boxes once you've built them. So I'm putting in the level 2 main effects for gender, age, and their interaction. And I have these labeled as between. Do you remember why that is? Why do they have to be between and not contextual in this case? Could they be contextual ever? If these are time invariant predictors measured once. We got 1 vote for no. I think we have 1 vote for yes. Are you nodding? Another vote for no. What's your vote? Another vote for no. I think we're split.
Oh, wait, you mean, okay, I was thinking like in a different study,
Ah, nope.
but no.
Nope. Yeah, these cannot be contextual ever, these ones, because there's nothing to control for at level 1. They're between. Age is measured once, gender is measured once. They have to be between. This one, you don't know what this is. And this is what I have a very vivid memory of sitting in an office in my second Lincoln House in Nebraska and finally figuring this out and just losing my mind. Like, I worked really like a long time, like, what is this number? And then I finally got it. And then I was so mad I had to write a whole paper about it. But this is part of the clue. There's an error message that shows up here. And it's not an error, it's a warning. It says, in the model command, the random regression predictor variable on the within level refers to the whole observed variable. To use the latent within level part, use estimator equals Bayes in the analysis. So refers to the whole variable is the key here to understanding this. So you would think that because I let the model figure out how much was between and within of both variables, that they would be between and within, right? No. In building this slope, it is not using just the within person circle part of mood 2, like the residual. It's not doing that. Like, back up to the picture here for a second. I would think that this would be what the path is going to, because it built these circles, right? It's not. That note, I'm back. Sorry for all the scrolling. Unfortunately difficult to avoid at this point. It is building this using the entire mood variable, the whole thing. So that means that I essentially have a constant centered level 1 predictor, and that means that the corresponding relationship between the random intercept for mood at level 2 and symptoms intercept at level 2 has to be the contextual effect. This warning message tells me that. So then I label it as such, con m to y, not trying to con you still, and then I have between person m to y as a linear combination of adding in the fixed slope that is registered as the mean of the latent variable here, plus the contextual slope for mood. And then we get back to something that looks analogous to the other side. So let me zoom out just a second. There, questions or comments? Any of that you want to hear again?
I guess with the making it contextual, is it always going to give you that warning so you know?
No.
Yeah, okay. Because I worry, like, how do you know, would it ever do the only within part of mood, or is the default always going to be contextual?
I'm so glad you asked. Let's look at model 2b. The difference is that because I only needed a fixed effect at level 1, I didn't need any random slope variance around it, I didn't need any cross-level interactions, I don't have to set it up this way. The more direct way to do it is just to put the level 1 slope in the within model. So then I don't have a within person m to y variable that's being created. This is literally just one fixed effect right here. And it's being labeled as such. So that label refers to the same idea as this. And now guess what happens? Because I took away the placeholder that technically wasn't needed and I put the level 1 slope here, it is referring then only to the E part, the within part. That means that the level 2 relationship of mood predicting symptoms is between and not contextual now. This is literally the same model, the same likelihood, the same everything. And 2 different ways of writing the syntax changes what the parameters mean. Now that wasn't what made me mad. That made me frustrated. What made me mad is that they published a paper when they started adding the Bayes side of this, and it was in it was an SEM, and it was phrased as a Teacher's Corner article, like they have a tutorial section of that journal that's very popular, and they tried to argue through a simulation that the Bayes version of the model that they had just invented in their new software was rendering more accurate answers, and that the answers provided by ML were biased. So we should all become Bayesians. What made me mad about that is that is not a fair comparison. Because I know that the ML version is giving me a contextual effect, whereas the Bayes version is giving me the between effect. They're not the same thing. It's not bias, it's a reparameterization. Yeah, thank you. Kendall shares my indignation. And so I was like, oh, hell no. And so I was so mad that I pounded out a paper in a week. And I was working, by then I was working at Kansas, had finished the book, and I was sharing this paper with some of the folks that I worked with at the Research Design and Analysis Unit. And it was the first draft of it was very difficult to understand, no surprise. And so they were like, can you please just put this in a table or something? And I thought that is a brilliant idea. So slide 28 is the table. So this is a paper that was published in 2019 about it, where I'm laying out all the possible ways that you can set up time-varying predictors in terms of whether they have fixed effects, random effects, what kind of syntax you have and what kind of estimator you have, and then what you get back as a result. So the punchline to their paper is that it wasn't bias. It was a reparameterization, and I did all the new commands to rearrange the parameters, and they mapped onto the third decimal place. It wasn't bias. Yeah, take that. So I don't like it when things are unnecessarily confusing. That's just a pet peeve of mine. So yeah, had I done it this way, then the within effect would have been using the circle, just the E part, not the full variable, rendering it something more like person mean centering. But in this context, we don't call it that. Do you know what we call it instead? It starts with an L. Latent centering, yeah. That is the term I think that I've seen most often. The key idea is that we are not carving up the variance in a time-varying predictor ourselves using observed variables. We are letting the model do it with latent variables, forming intercepts and residuals, just like we do for the outcome. That's the main point. In so doing, we can then have missing data on this predictor because now it's an outcome. Okay, so then the contextual effect is not add them up, it's subtract them down, between minus within. That works, doesn't it? Okay. Relative to the analogous model using observed variables, do I have the same number of parameters or do they differ? It's supposed to be the same model, except that the mediator is not being treated as an observed predictor, it's being carved up into its pieces. So what do we think? Is it the same model or is it a little bit different in terms of parameters and meaning? What do we think? It's a 50-50 shot. Same or different? One vote for different. 2 votes for different. 3. Okay, difference have it. Yeah, we got some extra stuff in here. So I have highlighted, let's see, how did I do this? Oh, I underlined, that's what I did. So I had to highlight different things. I have underlined in the output here on the left-hand column. This is from the original version of the model, where we have a contextual effect at level 2 because we use the placeholder notation at level 1. On the left-hand side over here, zoom into that. Things that are underlined are new parameters relative to what you would get out of Elmer or mixed in a univariate setting. Because now we have things like residual variance for mood. That's a parameter. We have intercept variance for mood as a parameter. And we have the mean for mood as a parameter. So essentially what has happened, we highlight, no, not that one, just this one, and that one. We've fit an empty model for mood. I got a fixed intercept, I got a random intercept variance, I got a residual variance. That's what we did. So there's 3 extra parameters in this model relative to what the comparable observed variable version would be. So the fixed effects are largely the same. The ones that we're focusing on here, I've put in bold so we can pay attention to those. So the first one here, let's roll through this. What does 2.34 mean? We can start with conceptually what it means and then try to put the coefficient in a sentence. I think that'll go better. Yes, it is. It is a slope. Excellent. Is it a level 2 slope or a level 1 slope? It is level 2. Mm-hmm. Yeah, it's not easy to tell because all the slopes are in the between level, and some of them are level 1 slopes. But this one has to be level 2 because what this is tying together is the random intercept for mood predicting the random intercept for symptoms. So if I put it in that language, for every unit higher random intercept in mood, the random intercept for symptoms goes up by 2.3. For every unit higher random intercept in mood, the random intercept for symptoms is higher by 2.3. That's great. What does that mean? Well, it's unclear, but what I would recommend in trying to figure out what the numbers actually mean in latent space is to refer to their variances. So like the variance in mood is very, very tiny. So a unit would be a very large amount of change. So I'd want to probably like compute a standard deviation or something to think about like what units are, but it would be the same thing as person mean negative mood. Like you'd want to know what the variance of that is to try and get a sense of that. So this is a level 2 slope, and in this model it is the contextual effect because this is tied to the use of the placeholder such that the within person effect actually shows up here. So then this one under means. Is that an intercept or a slope? Let's start there. 1.167 is what we're looking at. It's tricky. Because you'd think, well, it says mean, right? So shouldn't it be a mean? Is this an intercept or a slope? How do we think about it? A change in means? Sorta? This is a slope. It is the mean of the circle that forms the random slope for how within-person mood predicts within-person symptoms. But the circle has no variance, it only has a fixed effect. But because we use the placeholder notation, it shows up as the mean at level 2. So this is in fact a level 1 slope in the between model, as it is rendered here. I've gotten into semantic arguments during reviews of manuscripts because some people would call this a level 1 slope because it's tying the level 1 information together. Some people would call it a level 2 slope because it's stored in the output at level 2. I'm calling it level 1. Conceptually, that's what it means. So for every unit, let's go with more mood, higher mood, because this is level 1. So it's not relative to a person mean per se, but it is a within person effect. I still think you can think of it as for every unit grumpier than usual in this latent variable metric, then symptoms that day are worse by 0.17, and that's not significant. So the story so far looks to be grumpy people feel worse than other people. But if you are grumpier than usual, you don't feel worse than usual that day.
And what do you do about context? Is it just existing there?
It's existing, and there are paths from the circles to symptom circles. Yeah. So this mood effect is the contextual effect. So after controlling for like how grumpy you are today in an absolute sense, for every unit higher random intercept mood, random intercept symptoms goes up 2.3. And then like this is after controlling for grumpiness that day. If you want to not control, then the between effect is down here. And they're both significant, so the conclusion stays the same.
And what about the mood 2 and the means?
Mood 2 under means.
Is that just a new thing that we computed because we made it like?
Yes, that is a new thing that we've estimated because we've made it latent. Yep. That is the fixed intercept in the empty model that is simultaneously predicting mood as an outcome. So there's two different fixed intercepts in this output. One is here under means because it's not being predicted by anything else. The fixed intercept for symptoms is listed under intercepts because it is being predicted by something else. Conditional. Likewise, analogously, That is the random intercept variance for mood, listed under variances, because it's unconditional. It has not been predicted by anything. Whereas the random intercept left over for symptoms is listed under residual variances, because it is predicted by something. So if I put that together, if your variable is not being predicted by anything, it has a mean and a variance. If your variable is being predicted by something, it has an intercept and a residual variance. Had I brought, say, age into the likelihood because I had missing data, then also on this output would be the mean for age and the variance for age. We would be fitting an empty model, a single level empty model at level 2 for age in that case. Okay. Ready to see the other side? So I've highlighted what changes. The right side is consistent with this version of the model that does not use the placeholder. Therefore, the level 1 effect is between the E part of mood and the E part of symptoms, rendering this into a within-between version of the model rather than within contextual. Because the fixed effect is being requested directly in the within model here, it shows up in the within model here. So if we look at the coefficients, that's really the only way you would map this correctly. I have within level symptoms on mood. That sounds like a slope, right? What is it called on the other side? Find the point 167. Yeah, it's this thing. The mean of the latent variable that the placeholder defined on the left side. Either way, it's the level 1 fixed slope. The left side is a constant-centered version of it. The right side is a latent-centered version of it. Because of that difference in what mood 2 actually refers to, is whole self on the left-hand side, its E part on the right-hand side, that changes the level 2 effective mood into between here. So that slope matches the between effect we found through linear combinations, whereas the contextual slope at level 2 on the left-hand side matches what we got through linear combinations on the right-hand side, at least to 2 decimal places. It happens. There is a way, by the way, in M+ output that you can get more precision. It's super annoying. What it does is give you a text file with the numbers and, like, as many decimals as you want, not labeled whatsoever, just a string of numbers. So, fun. Hopefully M+ automation can do a better job at labeling that kind of stuff, because you just have to go like in some kind of order otherwise, and it's not always clear what it is. All right, are we having fun yet? Are we ready to do the whole thing at the same time? Yeah, we are. This is only 3 variables, folks. It's really not a big problem as far as mediation things are concerned. It's 3 variables and like 2 covariates. So the full model then is essentially concatenating all the code from both models so far at the same time. Why did I do them separately at first then? Do you remember my logic? Because if I could have gone straight to this step, why wouldn't I have done that? Pedagogy? No, I had a better reason than that. Although pedagogy is a good one. Do you remember my logic? Or can you give me your logic?
To see how they were, like, individually, and then in the whole model separately.
Yeah, I wanted to see how they were individually, or bivariately would be the word I'd use for that. Like, I want to know, is stress related to symptoms? Does X predict Y? Because the whole question about mediation is, does X predict Y differently after controlling for M? Differently is the key. That is commonly misconstrued as, did it predict and now it doesn't? Like, that's one way that difference can happen, but that's not a requirement. Differently is the key. So let's say that I found out in the giant model that stressors don't predict symptoms. Well, is that because they don't predict symptoms anymore after controlling for mood, or did they never predict it in the first place? That's what I want to know. So now I have the story sort of bivariately that it's the same story actually for both outcomes. Let's see here. For stressors, stressors does not have a level 1 relationship, but it does have a level 2 contextual effect as well as a level 2 between effect. If I go to the mood model, I come to the same conclusion. The level 1 fixed effect of mood predicting symptoms was not significant, whereas the level 2 contextual effect and the level 2 between effect were. So logically speaking, am I going to have mediation at the within-person level, do you think? No, if X didn't predict Y in the first place and M didn't predict Y in the first place, this ain't going to go well. Could I have it at the between level, level 2? Yeah, I do have relationships there that could be mediated. I do know that people who have more stressors have more symptoms, and people who are grumpier have more symptoms. So the question is the relationship between stressors and symptoms still there after I control for grumpy? Because the logic is, something bad happened, that made me grumpy, and now I feel like crap. I'll let my colleague in human development give the actual logic of that, but he had a story. Just trust me, it made sense. Hi, Rob, in case you're listening. It's his data. Okay, so we have the potential for mediation at least at level 2. I'm going to show you how to do it at both levels because you might want to know that at some point, so why not? All right, so step 3, the full model, changes then to the code. Stress is back on the within line, and person mean stress centered at 0.4 is back on the between line. Those are still observed boxes. Mood is not on either line, symptoms is not on either line. So we're saying carve those up into circles. Because stressors is an observed predictor, it does not have a residual variance being estimated in this model. But the other two do. So this is the point really where I would say the optimal strategy to examine mediation is in a simultaneous analysis. It is possible to do the pieces and output stuff and calculate standard errors. That's how people did it, for single level models, even back in the 70s and 80s. But in this context, this is why you could not do this model in univariate MLM, is because mood is both an outcome of stressors and a predictor of symptoms. It's an X and a Y at the same time, and that's where multivariate software is really the best way to do it. We've got 3 placeholders. X to M, X to Y, M to Y. So we're setting up the slopes that form the bottom triangle, the level 1 effects. I'm doing it with the placeholders, so I know that it is going to be the entire variable for the predictor that is predicting the outcome. So these are analogously like constant centered, because I'm in ML and not Bayes. If I were in Bayes, they would switch to being between instead of contextual. So I've got fixed intercepts and random intercept variances for symptoms and moods as outcomes in the level 2 model here. I do not have a fixed intercept or random intercept variance for stressors because it's being treated as an observed predictor. Then we have our within-person fixed effects. So 3 latent variables being created by the placeholders that get means, which are fixed slopes at level 1. And then each of those has its variance around that mean shut off so that we don't have random slopes. So my G matrix in this story is a 2 by 2 because I've got 2 random intercepts in it. My R matrix is also a 2 by 2 because I've got 2 residual variances in it. Then we get our between-person effects of age and gender as covariates. And then we get, finally, the level 2 analog of the fixed effects. Because we have, let's see, go back here. Because we have original stress predicting symptoms, original stress predicting mood, I know that the level 2 analogs have to be contextual. Because of the error message and the use of this placeholder, I know that the mood effect at level 2 has to be contextual as well, so I've labeled the 3 of those. So, any questions on the code thus far? We're not done yet. Drive over to the other side. Then we get the stuff we want to have. So directly what we have right now are level 1 within effects among the 3 variables, level 2 contextual effects among the 3 variables. So I'm going to build myself some between effects out of those, add them up, and then I'm going to compute indirect effects. So the logic, let me go back to, let's see, what page is this? This is page 6. Okay. Going back to the circle. Have you had discussions in other classes about indirect effects yet? I spent about 10 minutes on this in generalized linear models, so you might remember that. You're nodding. Zoomers, have you had indirect and direct effects in the context of mediation before? A little bit? What do you remember? The 10 minutes from generalized?
Yes.
I'm sure it has some other name in causal inference, though.
Oh, I don't know that.
You don't know that one? Okay, I'm sure it does. The idea here is that what we're trying to see is if, like, let's look at the level 2 path for simplicity here. I want to know if this path is different before this one gets added versus after. That's the question. So earlier versions of trying to figure that out would literally build like the difference in the slopes and then try to test that difference against 0. Well, some genius figured out that an algebraically equivalent version of that in many contexts and very close enough in others is to say if the product, not add them up, but multiply them up. If the product of this path right here and this path right here, and that's the language I'm switching to because I'm looking at a path model, these become paths. These are also known as direct effects. They're also known as slopes. They're fixed slopes. If the product of these paths is significantly different than 0, then the x to y path is different before versus after including m. The test of the product of these slopes is equivalent to saying, did this slope change after controlling for m? And I can do the same thing at the within level, even though it doesn't make a lot of sense given the pattern of the data here. That's the logic. Back to page 6. So that's my very last step here. This is the kind of thing that you cannot do like in a lincom or a GLHT. Those are linear combinations, and this is a multiplicative combination. You can do anything you want in M+. In Stata, I think it is NLCom instead of lincom. And then you can do nonlinear kinds of things. But those always involve just the fixed effects part of the model. The same is true in SAS estimate. Whereas you can do this to variances, you can do this to slopes, you can do this to anything. So like you can build a new parameter that is the ICC, for instance. When I teach structural equation modeling, we build new parameters that are omega reliabilities, for instance. Anything you want to build, you can build. So I have within person x to m times within person m to y. That's the multiplication of the top paths in the level 1 model. I've got, I want I capitalized, there. And I want that over. There, almost. Stop at word. There. I've done the same thing with the contextual effects, and I did the same thing with the between effects. So now I've got 3 different kinds of indirect effects I can talk about. And this is the point where folks who specialize in mediation analysis would be like, hey, you can't just do that. The problem is that we're going to get a hypothesis test for these indirect effects that assumes that they have a symmetric sampling distribution, that you can go 2 standard errors that way or that way. Anytime you have 2 things multiplied together, if they both have normal sampling distributions, the result is not normal. So it's not quite the right hypothesis test. To get around that, folks would often do some kind of other way of getting a p-value like bootstrapping. And for single level models in M+, that works just fine. However, it doesn't work with multi-level models. I'm sure you can find a way to do it in other packages, but here's a workaround. Chris Preacher. What you can do instead of bootstrapping the model is bootstrap the parameter estimates. So essentially you take your results and you plug it into his calculator and he does a resampling kind of thing to see what their ranges would be. I don't care about this. I just don't. I only have so much room in my head, and I got to protect it for the things that I really care about, like preventing smushing and understanding contextual effects. So I'm just going to be like, fine. Because in practice, whenever I've done it the right way, it's different in the third decimal place. And I'm like, I don't care. So you can add this to the list of things Lisa doesn't care about. Also on that list is mixture chi-square tests. Different in the third decimal place. I don't care. I teach it the right way, but in practice, it's like meh. So there. If you want to do it the right way, here's one option for that. And I'm sure there's other literature on other options that I'm not privy to because I don't care. There we go. Now we got the whole story at the same time. Let's just look at some numbers. So the only things that it looks like are at our within level are residual variances of symptoms and moods. Are these leftover residuals or just residuals? Time for another vote. Leftover? Leftover? Zoomers? Are these residual variances at level 1 the leftover kind or just residual variance because it's level 1 kind? More votes for leftover. The leftovers have it. Yes, it is. Because at this point, both of these things is being predicted. Symptoms is being predicted by stressors and mood. Mood is being predicted by stressors. So these are the leftover kinds of level 1 residual variances. Contextual effects, predicting symptoms. Does it still matter how many stressors you have after you control for how grumpy you are? This column is estimate, standard error, hypothesis test, p-value. What do you think? Does it matter? Does it matter how many stressors you have after you control for how grumpy you are? Looks like it. P-value, conventionally significant. Likewise, or that one, and this one too. So, still both significant. But did their effects change? I don't know. I could go back to the previous models and compare the numbers, but that's just eyeballing it. The indirect effects are the formal test of whether that changed. So we can skip down to that. Contextual indirect effect, wah, wah. Did not change. However, these are, go back to this, where was I? Here we go. These are the contextual effects after controlling for whether or not you actually had a stressor that day and how grumpy you were that day. What if you didn't want to control for those things and just talk about between-person differences? Can I do that? Is it in my model to get the between-person effects? It's implied, but it's not in there. That's why I had to add them up. So once I built my between effects, then I could multiply them to get my between indirect effect. And now my story just got a little more interesting. I do have different between effects after controlling for mood. I do not have different contextual effects after controlling for mood. And when I built this handout, I was like, damn it, how am I going to explain that? And I think I landed on that's what it is. There is evidence for mediation if I look at the between effects. There is not significant evidence if I look at the contextual effects. Either way, though, do I have within-person mediation? Doesn't look like it. So the effects are the same after controlling for mood, is what this is telling me. Where do I find them? If I want to look at the level 1 fixed slopes, go back to the model. Where are they? Guess? Zoomers can play too. Where are my level 1 fixed slopes hiding in this output? Yep. Ding, ding. They're right here. So x to m is significant. If I have a stressor that day, I am grumpier than usual that day. X to y is not significant. If I have a stressor that day, after controlling for how grumpy I am, I don't have more symptoms that day. And then m to y, after controlling for whether or not I had a stressor, if I'm grumpier that day, I don't feel worse that day. Yay! We did it! So this is a full, what is known as a 1-1-1 mediation model in the multi-level literature because it's amongst 3 level 1 variables. Let me scroll back to my picture. Here we go. So the reason that I have something for each variable at both levels is because they're all measured over time. What if I did not have daily stressors? What if I only had some kind of like personal stress scale that they gave out at the beginning? Just a level 2 variable. How does my picture change? Let me make it a little more concrete. If all I have is a stress variable that was measured once as a between-person covariate characteristic, whatever you want to call it. So I don't have an analogous variable here. What does that do to my capacity to examine mediation? Game over. I can still talk about how m relates to y, but there's no starter here. What if the same were true, I gave the PANIS to measure negative mood once and I didn't ask them about it each day? Can I have mediation at level 1? Nope. What if I only gave one inventory of symptoms? Can I have mediation at level 1? Nope. So there's logical constraints on how mediation can work in these things. And you have to have variance at that level for you to have an indirect effect at that level. Now, M plus doesn't care. Like, I could make an indirect effect that's this path, like at level 2, times like that path at level 1. And it would give me a number. I have no idea what that number means at that point, though. It's like the between thing times the within thing. What? So just beware that you may see examples of mediation that make 0 sense because you can multiply anything you want. But logically speaking, you have to have all 3 variables measured at level 1 for this to be possible. All right, 142. We hung in there. Yay! We've reached the point in this semester where staying awake during class deserves applause. So give yourselves a round of applause. And a standing ovation for showing up, even. Yeah, exactly. Round of applause. I would give you a standing ovation, but I'm not getting out of my chair. I'm too lazy. It's fine. All right. I don't get an ovation ever. That's the funniest thing is like when Vladimir leads examples in class, he gets a round of applause after he's done. I'm like, hey, what am I? So, no, I get a paycheck. That's what I get. That's my standing ovation is I get a paycheck. So, and you know, standing ovations don't buy you groceries. So I got to pick one. All right, let me know if you need anything as you're working on your project outlines. Thanks for being here. Have good weekends. Hope to see you next week. All right, bye for now.